Hello, folks. Welcome to one of my periodic installments of video blog for my blog, environmentalcentury.net. What I'm going to do tonight is talk about the financial industry, and in particular, talk about some calculation known as the social cost of carbon that has a tremendous impact on our lives in terms of whether or not we judge at the national, state, and municipal level and international level, it's valuable, just how valuable it is to reduce fossil fuels. In 2018, William Nordhaus, a Yale economist, won the Nobel Prize for creation of something called an integrated assessment model, and I'll explain what that is. And in Nordhaus's integrated assessment model, he argued that if we grow global GDP adequately, then the effects of climate change, the impacts of climate change would be negligible. Of course, he's quite wrong about that. And the reason I'm presenting this is to, I hope, uh, educate an interested viewer about the financial industry and the impediment it has posed to reducing fossil fuel emissions, and in fact, killing fossil fuel emissions, which is what we need to do. So I'll share my screen and we'll begin. So I entitled this "The Economic Models and the Real World Social Costs of Carbon." The economics literature, and indeed the entire field of economics as practiced in the standard representation of economics, does not adequately address the massive costs of failing to mitigate climate change as fast as possible. We need deep cuts in emissions now in order to avoid the dangers of climate change. The urgency of climate change can be understood through the metrics of economics, but only if the damage functions of economic models are realistic, not only in terms of their probability of how severe damages will be, but also the impacts of those severe damages. The World Economic Forum, which is held in Davos every year, in 2021 had a group of experts report to them on global risks. And they divided global risks into impact and likelihood. And risk categories included economic, environmental, geopolitical, societal, and technological. And one of the things to see right out of the gate is that climate action failure, extreme weather, human environmental damage, biodiversity loss, and natural resource crises are right at the top of the list. The only thing that slightly edges out in terms of impact is infectious disease. And in fact, this is appropriate in 2021 after the world had suffered the devastating impact of COVID-19 throughout the year of 2020. And of course, that's not over at this point. So the top risks are, as shown, extreme weather, climate action failure, human environmental damage, infectious diseases, and biodiversity loss. That's in terms of likelihood. In terms of impact, they judged infectious disease to have the most potentially severe impact. Climate action failure, weapons of mass destruction, number three, biodiversity loss and natural resources. There are a number of things to see here that are of interest. One is climate action failure edges out weapons of mass destruction. And it's not an action that the Bulletin of the Atomic Scientists now includes climate change along with its doomsday clock on weapons of mass destruction. It's arguable that, in fact, weapons of mass destruction are the only non-climate related factor in terms of the immediate impact of climate. Infectious diseases are, of course, affected by climate change. And One of the things that we need to grapple with is the concept of the moral hazard. A moral hazard, in an economic sense, occurs when someone increases their exposure to risk, but someone else bears most of the cost of those risks. If we look at the per capita emissions, which can be calculated as an index, we see that countries with the highest per capita CO2 emissions have the lowest climate demographic vulnerability index, such as the United States, Europe. And if we look at where the most vulnerability is, it's in the global south, Africa, especially parts of South America. And most of the CO2 emissions per capita come from the global north, with the exception of Australia. And if we look at the United States in particular, I would argue that if morality means anything, that we have a moral responsibility to lead on climate change. Most of the emissions that have accumulated into the air since the Industrial Revolution came from the United States in terms of fossil emissions and land use change. This ranking of the US, China, Russia, et cetera, does not change if we include exported and imported carbon emissions in terms of real world goods that are moved across international borders. The responsibility for loss and damage has been a major topic of discussion at the COP27. Many of us, including myself, regard the COP27 as an abysmal failure. It really is embarrassing how awful it was. And of course, the next conference of the parties will be in Dubai, the showcase city of a petrostate. These are the countries that have caused the most economic damage to the rest of the world, as calculated in this peer-reviewed paper by Callahan and Mencken. The United States, of course, is at the top of the list. China comes in second. The US, China, Russia, India, and Brazil have collectively caused 6 trillion in income losses from warming since 1990. That's approximately 11% of the global GDP. If we look at this artificial construct called the social cost of carbon, we calculate that as the intersection of the marginal benefits or avoided impacts and the marginal costs of reducing 1 ton of emissions. And it works as follows. Economic theory mandates that it is worth reducing CO2 emissions up to the point where benefits are equal to the cost. Okay, fair enough. The social cost of carbon is an estimate in dollars of the economic damages from emitting 1 additional ton of greenhouse gases into the atmosphere. Of course, how these economic damages are estimated is of critical importance. This is inextricably tied to neoliberal economics, and it's used by the United Nations and all governments to determine the appropriate investment in mitigation. The cost benefit depends on the discount rate and, secondly, on accurate measures of the costs. We'll talk about both of these throughout the remainder of this presentation. If we look at an artificial social cost of carbon arbitrarily set to be $80 to $200 per ton of CO2. Of course, that's higher than any social cost of carbon that's ever been used by the United States until very recently. This does not include the public health impact, species extinction. We are on the verge of the 6th grade extinction. Property damage and loss, agricultural productivity loss, cost of famine, increased food prices, compromised ecosystem services, and conflict, which typically increases with warming. If we look at some of the calculations of the social cost of carbon, it's easy to see that the social cost of carbon will never result in a valid price of carbon, for the following reasons. 1, many of the costs cannot be assessed until the damage is done. Many of the damages are cumulative. In fact, most of them are, and they're permanent in many cases. Accurately pricing carbon would make the use of fossil fuels economically unviable. It would kill the industry, which many of us think is, in fact, the goal. Continued price supports for fossil fuels discounts the social costs of continued use. So the more we subsidize fossil fuels, the less likely we are to have an accurate assessment of what the social costs are and the damage that that does. A high discount rate, which I'll define in a minute, is equivalent to a low calculated social cost of carbon. If we look in terms of billions of 2011 dollars, the costs overall in this red box are the direct subsidies and economic value of fossil fuels. If we look at the calculated social cost of carbon in 2008, it was calculated to be less than the value of the fossil fuels plus their subsidies. And in 2013, which is the highest until very recently that the social cost has ever been, it was somewhere between 15 and 20 billion dollars in terms of 2011 dollars. Using the social costs of carbon to calculate the costs and benefits of emissions is illustrated in this example. In this example, the social cost of carbon has been calculated to be $50 per ton of CO2. So in scenario A, an increase of emissions of 500,000 tons at $50 per ton of the social cost of carbon CO2 is $25 million costs of policy A. Policy B is where we decrease emissions by 500,000 tons, and that's equivalent to $25 million of benefit of policy B due to decreased in emissions. Now, this is modified tremendously by something known as the discount rate. If we look at a given amount of money today and what we could use that money for now and the interest rate that we could acquire from lending that money now versus the impact of saving the money and applying it to future cash flows, or in this case, the concrete example of mitigation of climate change. The discount rate is the difference between the two. In other words, money used now is generally of higher value than money that's applied to future cash flow. So the discount rate takes that future money and discounts it in terms of today's dollars. If the value is positive, then the investment is feasible. If it's negative, then the investment is not feasible. The discount rate is the rate of investment that is used to discount the future value of an investment relative to the value of investing that money now. In the present value, if we invest it now, we're going to get compounded interest, which is analogous to the interest rate on your mortgage. If we invested in something of future value, then we have to discount it relative to what that value would be if we had invested it now in terms of the present value. So if you think about that for a minute, it makes sense, but only in the sense that we're talking about things like the widgets on an assembly line, or maybe the production of automobiles, or maybe housing, mortgage, or maybe lending money to an international entity. So allowing that another country to accrue debt. It only works in those strict financial senses. But if in fact we're looking at the impact of climate change, where we often don't know the impacts until they have been compounded and are permanent, then it really doesn't make any sense at all to use a discount rate. So in 2006, Sir Nicholas Stern and his team were commissioned by the British government to create a study of climate change. Stern was the British Exchequer, which is roughly analogous to the US Secretary of the Treasury. Stern and his team were troubled by how to apply a discount rate to the value of human lives in the future, because this entailed a moral judgment. The report issued in 2006 found the following findings. The benefits of strong early action outweigh the costs. Irreversibility, when damages appear, it will be too late to reverse the process. The annual cost of achieving stabilization at CO2 equivalents at 550 parts per million is, at that time, they thought 1% of the global GDP. We now know that it could be much higher than that, especially given the damages that 550 parts per million can do. So damage to the world economy in 2100 of business as usual would be very large due to higher costs of adaptation. And they used a discount rate of 1.4% based on the moral or ethical equivalence of future generations. The criticisms are very predictable. The discount rate is too low, thus minimizing the opportunity costs of short-term capital used for very long-term benefit. The social cost of climate change is estimated to be too high. The damage estimates are too high, and the costs assigned to mitigation were too low. Of course, all of these criticisms turn out to be moot or simply wrong. Gary Yo published a paper with Turpak in 2008, in which he showed that risk management is the appropriate approach rather than cost-benefit analysis when future events are uncertain, but we know that some version of them will occur. So he said Stern is right to argue for immediate action, but for the wrong reasons. If climate change damages are real and increasing, the least cost approach necessarily involves starting now. The economics of climate policy support the conclusion that it is time to act because claims that climate is not changing are now indefensible. Precautionary principles should be applied. Once you adopt a risk management perspective, then uncertainty becomes a reason to do something rather than a reason not to do something. Makes sense if you think about it. At least twice now, Nicholas Stern has said, looking back, I underestimated the risks. He's modified that twice into much underestimated the risks. The planet and atmosphere seem to be absorbing less carbon than we expected, and emissions are rising pretty strongly. Some of the effects are coming through more quickly than we thought then. In fact, this last sentence applies to climate scientists as well. We're frequently really surprised by how extreme climate change has become and how fast it's become that. Well, there's something called Earth System and Integrated Assessment Models. Let's first look at the Earth System Models, or the ESMs. They help us view the dynamic processes that govern the climate and the biosphere through time. So the atmosphere, the geosphere, the hydrosphere, and the biosphere constitute the simplest version of an Earth system model. This includes natural cycles, carbon, water, nitrogen, phosphorus, sulfur, etc., and deep Earth processes. Integrated assessment models add human beings and a massive social, ecological system and economic system, including human interactions with the Earth system. How life affects carbon, nitrogen, water, oxygen, and many other cycles and processes, but these are mediated by the social ecological effects that are defined by the human economy for the most part. In 2018, I mentioned Nobel Prize winner for economics was William Nordhaus, the Yale economist. He's revered among economists, but less so by climate scientists and certainly not by ecologists. We regard this Nobel Prize as a prize for climate catastrophe. In the 1990s, Nordhaus invented the first integrated assessment model to explore how climate change affects economic growth. And this is called DICE, the Dynamic Integrated Climate Economy Model. Nordhaus overemphasizes the uncertainty associated with climate change and adjudicates that in favor of less mitigation and less investment in mitigation rather than more, as Gary Yo would have argued. So he's written a textbook that sadly I take great issue with. It's used widely in mainstream economics, environmental economics courses in major universities, including at the University of Florida. It's called The Climate Casino. And again, it places the emphasis on the wrong aspect of climate change and reflects a failure to understand the real physics of climate change. The DICE model continues to drive economic models of the IPCC used for calculation by the social cost of carbon, calculation of the social cost of carbon by most governments. Models show that if we rapidly reduce carbon emissions as needed to avoid climate disaster, this would significantly damage economic growth. Some of us don't regard that as all that bad, frankly. But Nordhaus used his models to argue for a balance between climate mitigation and GDP growth. So if we look at Nordhaus's 6% discount rate, which was the standard discount rate applied to climate change at that time in the early 1990s when he invented DICE, $1 trillion is worth only 2.5 billion, excuse me, 100 years from now. Sir Nicholas Stern's 1.4% discount rate places a relatively high value on the well-being of future generations, and $1 trillion of goods is worth over $250 million today, valued at $250 million today. In fact, Stern argues the world will needs to begin investing at least 1% of its total production, or about $500 billion each year, in efforts to reduce greenhouse gases. Nordhaus, on the other hand, argues that 2.5 billion is hardly enough to justify the costs of greatly reducing greenhouse gases. Well, over $250 million versus 2.5 billion. Well, the real issue is which is worse, the death of a child in 100 years or the death of a child today? Well, I'll let you think about that question, but we can put it in a broader context. Is it moral or ethical or even possible to assign an economic value to human productivity and well-being 100 years from now? Parenthetically, let me say that I often use ethical and moral interchangeably because most students don't know the difference between the two. And I define morality largely as an evolutionarily derived characteristic of an obligate social primate, Homo sapiens. Ethical tends to be more profession-oriented and rules of engagement oriented, or rules of the game. So don't be too troubled by the difference between the two in this presentation. So Nicholas Stern uses the term ethical frequently, but other authors use the term moral. I think it's a moral imperative myself. So what is the effect of the discount rate on the calculation of the social cost of carbon? If, when the discount rate is high, the social cost of carbon is less than $15 a ton. When the discount rate is only 2.5%, the social cost of carbon rises, but only to $75 per ton. We know that a realistic social cost of carbon is much higher than that. To make the IAMs and DICE consistent with acceptable economic outcomes, Nordhaus manipulates the discount rate to a high value such that damages to future generations are discounted or valued less than current damage. He states without evidence that this damage will be relatively low. Nordhaus's models indicate even catastrophic climate change will not hurt the global economy all that much. The global economy will simply grow sufficiently to make the damage modest. This ignores many real-world effects, permanent damages, and interactions of multiple impacts resulting in amplified overall damage. He's famous for saying, "Don't let anyone distract you from the work at hand, which is economic growth." The importance of GDP growth in the IAMs is really apparent. An early version of DICE resulted in negligible impact on GDP if warming were as high as 4 degrees Celsius. Most ecologists regard 4 degrees Celsius as ending civilization. The best estimates I've seen put us between 500 million and a billion people on Earth at that point in time, with massive readjustment of many aspects of human civilization. So, in effect, human civilization is very unlikely at 4 degrees Celsius. Using the social cost of carbon to calculate the cost benefits of changing emissions is a multi-step process. First, you predict future emissions based on population, economic growth, etc. Model future climate responses such as temperature increase and sea level rise, which are typically assumed to be linear in these economic models, but we know they're not. They're curvilinear, and there's certainly many of them have threshold effects. Calibrate the IAM results to implement economic guardrails, not social impact guardrails. And these guardrails guard against economic extremes rather than the means. And convert the future damages into their present day value using an economically accepted discount rate. And then you add up the damages. Well, gee, an economically accepted discount rate is really an absurd proposition when it comes to the damage that climate change can really do. So there are 7 ingredients for calculating the social cost of carbon. The first is uncertainty, which is very, very difficult to nail down. Socioeconomic and emissions pathways, which are developed by the IPCC, and climate models, which are essentially Earth system models. And then we apply a damage function, which of course needs to be realistic. And then we apply the discount function. If we're really progressive, then we'll include things like equity and global versus domestic damages in our damage functions and our discounting. And ultimately, this results in the social cost of carbon. So the key messages here are that most studies use standard cost benefit analysis with high discount rates. This results in a low social cost of carbon inappropriate to the damages being done now and in the future. Nordhaus's versions of DICE reflect calibration to allow feasible economics. And damage functions are ad hoc and not grounded in real world data. So if we look at how climate models interact with economic models. So we take an Earth system model where we look at CO2 equivalent concentration projections from past, current, and future estimates. And we calculate the sensitivity of the climate to those emissions. And then we calculate the economic impact in the economic model. And then we impact estimation, and then we essentially calculate what it would cost. And so this six-step process, we note that the IAMs differ in extent to which they include threshold effects, tipping points, and feedbacks from biological systems and ecosystems. And the IAMs are built by economists such as Nordhaus. They often have wildly unrealistic, greatly underestimated risks. Here's an example of how absurd DICE was in the early days of its formulation. This is from 1991. Nordhaus estimated that the total negligible effect of climate change would be about 85% or 86.9% of GDP, because this would be not exposed to the climate. In other words, a lot of it was done indoors. It uses the relationship between temperature and GDP today as a proxy for the impact of warming over time. And that's clearly inappropriate, because the impact of the relationship between temperature and GDP is a dynamically changing function. It uses expert surveys to dilute the extreme warnings from scientists with optimistic expectations from economists. And in fact, the expert opinions that Nordhaus used about climate change came mostly from economists and not from climate scientists. It misrepresents the scientific literature to justify using a smooth function to describe damage to GDP. That is, it does not include increasing rate functions, nor does it include tipping points. So the standard economic revision of the SCC, as recommended to the Biden administration when it first came on deck, was a two-step process. One was immediate changes, and the other was a comprehensive update. So the immediate changes are to reverse Trump's changes. Trump's policies resulted in a social cost much too low to cause an incentive for mitigation. It's less than $10 per ton of CO2 equivalents. And the pre-Trump SCC is about $50 for the US, but this is easily $200 too low. And the literature that I think is credible says it's $300 to $400 too low. We need to update the damage functions to include ongoing and accelerating damages, and reappraise climate risks to include permanent damages and account for extremes and surprises. Of course, this is all still built on a cost-benefit analysis. Address equity issues, international, and intergenerational, and revise the discount rate downward to account for normative values, in other words, value judgments about what it should be, and more realistic damage functions. Acknowledge the limitations of the standard social cost of carbon to include the real and comprehensive damages that include externalities and market failures. So in other words, stay with the cost-benefit analysis, but acknowledge that it's limited in its ability to really tell us what's going on in terms of comprehensive damages and market failures. Well, there are some good guys in this story, and of course, they are Nicholas Stern, his long-time colleague Charlotte Taylor, and Joseph Stiglitz, who is at Columbia University. These guys have done some excellent work. The IAMs are inappropriate for estimation of the social cost of carbon because they do not include growth opportunities offered by taking action to address climate change. There's real economic advantage to addressing climate change. They do not include accurate assessments of damages to the global economy from climate change. That is, GDP is considered to a large extent exogenous to the entire process. It does not account for high levels of uncertainty and extreme risks associated with climate change. Models assume that there is an optimal cost-benefit function for mitigation, and physics doesn't give a rat's ass. This is not consistent with simple physics. Physics does not optimize anything. Only human beings and economists optimize things. It deals with globally or regionally averaged economic variables and thus masks most inequalities of climate impacts. Discount rates of 3 to 7% are indefensible because The rates depend on the valuation of future life relative to one now and economic conditions in the future relative to those now. There's no ethical argument for discounting the valuation of future life, no moral argument, certainly. Social normative values and willingness to trade off income now with that of future generations does not include intergenerational impacts. And believe me, if you're in a college classroom now talking about climate change, you know that the students in the classrooms today are acutely aware of intergenerational impacts. Damage functions are unrealistic and cannot be used to justify a high discount rate. An appropriate discount rate, they argue, is no higher than 2% and probably much lower than that. The alternative, a target consistent social cost of carbon, set as the objective to limit warming to well below 2 degrees C, as stated in the Paris Agreement of December 2015. Commit to reaching net zero emissions by 2050. The costs associated with greenhouse gas mitigation to meet these goals informs the calculation of the social cost of carbon and the least cost pathway, not the optimal cost benefit pathway. Why is this important? Well, it's important because on the left is where we are now. We've got massive deforestation, we got flooding, we got landslides, we got retreat and loss of glaciers, which is completely changing our world. We've got reduced food security, we've got desertification, overgrazing, alien plants, essentially invasives, and many coastal impacts and many ocean impacts. We're going to lose our corals. And what we could have is the biodiversity benefits shown on the right here. We've got a long way to go in terms of reconstruction and revitalization of the living portion of the planet, including how we do agriculture. The reason we care about the financial industry and the social cost of carbon is that the science is now crystal clear. Hans Otto Portner, co-chair of Working Group 2, says any further delay in concerted global action will miss a brief and rapidly closing window to secure a livable future. Well, the White House Working Group on Social Cost of Carbon. So what do? Flip a coin? Well, traditional calculation of the social cost of carbon should be replaced by economics based on risk management, which Stern, Charlotte Taylor, and Stiglitz all agree now. Economics should be tailored to match the impacts rather than this ridiculous pretense that the impacts will match acceptable economics. And here are some references if you would like to track some of them. So thank you for watching. I hope this has been informative. I hope it's been valuable. I hope you've gained something from it. I do hope you will spend some time with this and to share the news about the financial industry and this ridiculous proposition known as the social cost of carbon. I hope that you'll come back and follow more of my installments on climate change. And bye-bye, folks. Everybody be well.